Welcome to the Internet of Things equation, a podcast when I talk about the Internet of Things domain both from the technical and business perspectives. I'm Łukasz Malinowski, the Internet of Things advisor and trainer. Smart energy domain is constantly evolving, utilizing the Internet of Things capabilities. My today's guest has actively participated in the energy domain for over 20 years. That means before it started to be called the smart energy. Hello, Thomas. Thank you so much for joining me today.
Thanks, Lukasz, for having me. It's great pleasure to talking to you.
Over 20 years of experience in the energy market. Could you share your track record and give us some better feeling of how the energy market evolved over the years?
I started with, let's say, with digitization in the energy market back in the year 2005, 6, 7. It was at that time a marketing agency, and we talked a lot about service providing, printing on demand, and let's say end customer service, because it was the time of the unbundling and the liberalization of the energy market. So it was more or less consumer focused. If you look into the, let's say, real interesting things in the energy market, they're mostly infrastructure related and more on the interfaces between the networks, the monopolies of the grid, and the end customer. So one of the major discussions we had already in the 2006, 7, 8 was how to integrate meter value into this system, into the consumer information system. And once you dig into this, you enter the sphere of what we today call IoT. At that time, this expression didn't exist. It was, let's say, there was an Ericsson research of about 28 billion devices to be connected in the year 2020. It depends on how you count it, but at least in the B2B market, never reached. So at this time, we were discussing already how to integrate metering data into consumer communication to make consumers stick to your brand, stick to your product or to your supply. But at that time, the products were not flexible, meaning you didn't have flexible tariffs, you had nothing. In Germany, it's still the case. In many other countries, it changed. And at that time, smart metering came up. And let's say the domain I was focusing on or was jumping in when moving from the consultancy world into a product world was around 2009-10. I joined a company at that time called Cinterion, which was acquired by a French company called Gemalto, which is literally a security and SIM card company that recently has been again acquired by Thales, but that's a longer story. I left 2017. And at that time, IoT was called M2M, machine-to-machine communications. And Cinterion was a spin-off of Siemens. So at that time, these were the experts for machine-to-machine communication, 2G, 3G modems that you put into expensive machines with a SIM card and they connect directly to the mobile network. At that time, there was the first rollouts happening in Europe, in Sweden and Italy. But also all other countries were designing their smart metering solutions. And if you look to the US in 2008, the Obama administration did a similar thing as the Biden administration does today with the Inflation Reduction Act. At that time, it was called stimulus funds after the financial crisis, 2008. And one of the things they were enforcing or subsidizing was exactly the smart metering rollout in the US, in the different states, with a different motivation than, for example, in Europe. In the US, it was really about getting along with the increase of energy demand in the, let's say, pretty vulnerable networks. So it was less like in Europe on consumer benefits and liberalization. There it was really about infrastructure utilization and efficiency. And here it was, getting, let's say, there are several use cases you can discuss, like the so-called non-technical losses, which can translate in theft. And Europe had a very much more fragmented motivation to do smart metering. And as said, if you look into Eastern European countries or into Germany, the rollout has not yet started because of, let's say, some inertia in making the business case clear. I was responsible in Gemalto for the, let's say, go-to-market strategy for the energy segment. I did a lot of work in for example, in Brussels around security, because Gemalto was or is a security company running banking, running telecom SIM card applications on the secure chips, and knowing their stuff extremely well, and looking at the time, one of the biggest threats in the IoT and in the smart metering domain was the hacking of smart meters or systems via the smart meters, in getting into utility systems, and then the vulnerability of entering, let's say, critical infrastructures. We are much more mature today, but this was groundwork that we did in Brussels. It was not only connectivity, it was also security. And through security, we also realized that centralized systems are always much more vulnerable than decentralized systems. And then on top of the, let's say, of the consumer motivation to get flexible tariffs and to know your own consumption, to control your cost, the second use case that kicked in over the time was the integration of renewable assets into the grid. Yeah, so all of a sudden we had a very much a change in paradigm of how we run energy systems. On the grid edge, we can lift a lot of potential by flexibilizing this. This has not happened yet for regulatory reasons, because you also need to change revenue streams or money streams in the system. A smart meter is the starting point for enabling this, but there's a second requirement, which is communication. And in communication, you also need a decentralized communication, because the energy grid is decentralizing. It's not non-determined, but if you replace one monopoly by another one, let's say a grid monopoly by a telecoms monopoly that controls the data traffic and data handling, nothing is won, because the margins will be the very thin margins that we see in IoT when you go in the massive IoT market will be eaten very fastly by different players of the stack who believe that this is their future. And this is where Wirepas comes into play, because Wirepas is, I met Wirepas first in 2017, when they have won, or we have won, I can now, after 7 years, I can say we have won a partner in Northern Europe called IDON, which is one of the largest smart meter manufacturer and a system supplier, solution supplier in the Nordics, and started to install smart metering mesh infrastructures in Norway first, and now Sweden and Finland, with let's say a meter base today of around 4 million meters installed with our technology. The revolutionary thing is that these meters are forming a network. So you do not need an additional network provider, an additional middleman that is running the service to get the data from the meter into the head-end system. It is the utility itself that buys the meters, and with the help of IDON, they're creating the network with the meters themselves, and that's a kind of revolutionary. The total cost of ownership for the utility for the metering system is significantly lower, and the maintenance effort and installation effort is even more performant than anything I have seen in the last 20 years as let's say observer or participant in these kind of smart metering projects around the globe.
Let me break it down for the audience, and we can take piece by piece of your story and the story of evolution of the energy market, and try to navigate. First of all, you mentioned that switch from machine to machine to the IoT approach, and from my perspective, the one of biggest potentials of IoT is creating those ecosystems. So devices are forming ecosystems to provide some kind of business benefits. Depending on the use case, those benefits might vary. And this is exactly what you just covered in the introduction, that the smart meters are forming that ecosystem using mesh networks, and we will dive into mesh networks in a second. But for now, let's focus on the business value? Because you mentioned that depending on the geographical location, that business value differs from the vendor oriented to the end user oriented to the operator oriented. So let's start with that, and let's start from the end customers. What value can smart meter installed in my home give me? What's your point on that? Like, where is the selling point, and where is the actual benefit for the end customer?
Let's start with my personal view on IoT. So the value is not the device itself. The device is a sensor, and the sensor generates data. There was a famous saying in the Web 2.0 world where it says it's user-generated data. So your behavior in your household, how you use electricity, is recorded and sensed in this device, and then it's sent somewhere. And then the question is, what does the recipient of the data, how does he create value out of the data, and how is he entitled to create value out of the data? And the value could either be in the, let's say, system side, not really touching the customer, but ending up in lower cost for the network and lower cost for the energy supply and for the quality of supply. That's an indirect effect, yeah. But the other, and you get accurate bills, whatever frequency you get your invoicing or your settlements. Into several countries, there is a significant reduction of energy theft through smart meters, because you detect immediately if somebody manipulates and just bypasses the line, so that you have a better distribution of the cost to all users of the energy grid. And then for you individually, the advantages vary very much on how the grid infrastructure, how the system looks like in your place. Yeah, if you do not have, let's say, like 10 years, go back 10 years ago, yeah, you had mainly coal power plants, you mainly had nuclear power plants, a lot of base load, very little benefit from flexibility in, let's say, at least on the level of a household. Yeah, you get a nice curve of your consumption. You can save a little bit by detecting energy, let's say, eaters. Like I detected when I did this, that my coffee machine is a very much when it's plugged in, so I plug it off. But that's a one-off effect. After half a year, most likely, I will not look at. I have optimized and I will not look at that again. Now, 10 years later, we have this situation that general electrification is coming. So you have a lot of solar on your rooftops, you have electrical vehicle charging, you have heat pumps. Like in Germany, it's now a big discussion to have a very large replacement of gas and oil heating by heat pumps, which are electrified. And so the electricity consumption for your household or for your house is getting more and more relevant to your share of wallet. And this comes together with the regulatory invention, which is, for example, in the Nordics already in place since a couple of years, which is flexible tariffing. So companies like brands like Tibber and Octopus from the UK and a couple of others are now offering to you a flexible tariff. So your behavior determines really how you're invoicing, how your share of wallet for electricity looks like. And this cannot be done without a smart meter, without without a digital metering system where data is generated and transported in a certain frequency. In the Nordics, I think it's a 15-minute values that you can change your tariff. It's 10 years ago, you would have called this a supplier change, which was a process of in Germany, about 100 pages of flowcharts between different actors, how they change it. Now this is a purely digitized process, at least in some countries. Yeah? And this is the benefit you get. If it's always about lower cost, lower price of the kilowatt hour, I doubt it. Yeah? But it's about your influence, your control, and your way of integrating energy into your behavioral patterns. Yeah? And the tools that are created, the new business models that are enabled. Yeah, if you look at how electric vehicles now become part of the storage for the grid, and how EV manufacturers are already looking into these models and maybe aggregating the load of their fleet, that then they pay you for with lower kilowatt hour cost, so that you offer or provide them for a certain time your battery as a resource. There's a lot of, let's say, moving in the market, and regulation must adopt this. And the main challenge or the main advantage of this smart meter is that it if it's designed well, if the design principle and the let's say the future proofness of the smart metering system is there, then this enables, or this has a lot of potential to be a booster of the energy transition on one hand, but also of your own transition and your own carbon footprint, but also your own wallet. And I think the last point is the most important one for most people.
At least as the entry point, as you said, that it will enable you to save money, and once you understand the concept a bit better, then you can use it in a more mature way.
Exactly.
So I got one question for you, because when I speak with my customers and they propose to create the profiles of users, privacy of the end user is the topic that always pops up. So how can we provide all of that while respecting the end user's privacy? How is it embedded into smart meters that they can respect privacy while creating those end users profiles, so everyone wins?
So I'm not talking Europe, because I'm responsible for the European market. There are many, because you have different market structures. Yeah? Even in France, you have one big player who controls 90% of the market of the smart meter rollout, while in Germany you have 450. In Switzerland, you even have 700 different distribution grid operators. So this topic is handled differently in these different systems. The main message I could send here is that there is some rules, and one of the rules is the minimum data rule. So each player should only possess of your personal data that he needs to process his service, and this can be very easily defined by the for the regulated part of the market, like the grid operators who are collecting the data. Yeah. The other thing is encryption. Yeah, so data needs to be encrypted and needs to be protected in the databases, so that only you, as an owner of the data, as the generator of the data, have access to. All this is, in one way or the other, designed in the smart metering rollouts all across Europe. There was a discussion about 7 to 8 years ago. This has been solved through standards, standard definitions, standard approaches, regulation from the European Union, and also the learnings that the different players and actors have gone through in the last couple of years. If you look into Germany, this privacy topic was a design constrained topic, which ended up in, for example, this extreme complex definition of the architecture that we have in Germany, where you have other use cases than meter to cash determining the value of the smart metering system. And that's because that's why we are in Germany where we are, and other countries like in the Nordics are a bit further, who are a bit more pragmatic in handling this privacy topic, but not against the interest of the citizens and the consumers. Politicians cannot afford that this is happening, that private companies are abusing the personal data of the people.
From my perspective, that's always the case, that you need to find the crucial data, the subset of data that is really confidential. And as you said, we can encrypt that. We can encrypt that on the end device. So we ensure that this is encrypted both in transit and at rest in the database. And there is some generic data that does not really reveal any secrets of my private life. And sharing that does not put me at harm in any ways, while it enables grid operator to really benefit from that data.
Exactly. You get a lot of anonymized data out of the meters by default, already from the source. Like power quality data is never connected to your meter as such, as your person as such. Yeah? The grid operator just sees that this point has a power quality problem potentially and can act inside his network. And let me also say that it's not just a technology topic with the privacy, it's also a process topic and a people topic inside the companies that handle the data. And also here a lot of effort has been put in, a lot of audits, a lot of change management has happened in the last couple of years, especially on the utility side. They've taken a lot of effort into.
Well, technology is just a tool, and it's all about of people
Exactly.
that are using that tool, if they use it correctly or if they want to abuse that technology to generate some profits. But those are profits in a very short time, right? Because after that, everyone understands that this is not the best way, and they will just lose money. You mentioned a very interesting topic, which is creating mesh of those sensors in order to minimize cost, to create self-healing systems. Could you elaborate a bit on that? This is very interesting capability that we can create independent connectivity, right? We do not have to purchase that connectivity from external operator. We can create our own mesh that gives huge potential.
Yes, that was one of my personal motivations to join Wirepas as a then 20 people company, with a very interesting technology approach, fitting perfectly for smart metering, which was the domain or smart energy domains, where I was working in for years. And let me go back to the initial years of Wirepas technology. It started in 2000 when there was a research cluster in Tampere University. And this research cluster took a topic which was a kind of future topic. Yeah? What happens? How do we get as many sensors or radio nodes into one dedicated spectrum without losing the reliability? And a couple of let's say, iterations later, it was clear that this can only happen with adaptive mesh networks. Use one device as a router for the other one, yeah, which was at that time already existing, but these routers have taken a lot of power. There was a very high power consumption on these routers. And so how do we get the power down for these routers? This was the research cluster where the original Wirepas stack and IP has been created over 10 years, from 2000 to 2010. So the company dates back to 2010, and the technology dates back. I would say the first source code lines were written in 2001. So there's a huge experience of testing and analyzing already integrated in what this mesh is doing. And then in 2010, and maybe this is also a good learning for all, why we are seeing an inertia, especially in the massive IoT. We had a brilliant stack which was small enough to fit on the now performant enough chipsets. So we baked this in. And then we were looking for a so-called, this was a term of the 2010, killer application. We know the most complex part, which is connectivity. Couldn't be so difficult to build hardware, couldn't be so difficult to build dashboard and cloud system or backend system. Let's do it. And let's build end-to-end solutions. And this works with the first application, the first solution was very successful. At that time, it was a control of the landline networks in the Nordics with sub-gigahertz meshing. So they had some clamps, and they saw when there was an outage in the winter, they could detect where this outage happened, where the tree fell on the landline, which was a super good solution. But then the next application is killing your case, because you have to start from the scratch again, building a device, building a backend system. And the utility at that time were so happy that they said, okay, we want smart metering with this. And now build a smart meter within a couple of years, weeks, or with your investment funds, and build a head-end system with you. That doesn't work. So we have taken the decision to focus on our own competence layer, which is, in that case, in the OSI layers, MAC transport and routing layer. packaged this as a piece of software, as a stack, as a technology with an SDK running on off-the-shelf chipsets and offering this to people who understand the application world. In that case, let's take the best example in smart metering. It was IDON using the stack of for the spectrum, the profile of the radio regulation in the Nordics, 868, 870, taking this into their existing smart meter for the connectivity. Yeah, and then managing these devices via their head-end system together with the utility. And this was the investment, this was shrinking the investment for the overall system massively over the idea of Wirepas becoming a full stack smart metering provider. So we were focusing on our competences, and we see in IoT, we see this more and more, what you mentioned in the beginning, ecosystem creation. Everybody focuses on one layer where he's very good at, or she is very good at, and then the ecosystems are created through the interfaces and collaboration between the companies. So we are licensing out our stack to anyone who wants to build these kind of networks. And we are offering a profile for 2.4 gigahertz since a while, where we are also working successfully with around 100 companies in other domains, mainly in asset tracking, in smart building, lighting, and condition monitoring. And we were a bit stuck in the smart metering because in Europe, radio regulations were so scattered that we could not transfer the profile, for example, to the Central European sub-gigahertz bands, because they have different bandwidth and they're not in favor of mesh networks. Don't go into details here. So we had to look, where do we find a standard? Where do we find a spectrum that works like the 2.4 gigahertz for the, let's say, short-range devices, that works for the mid-range devices? And we were teaming up, again, ecosystem approach, with the DECT community, DECT, which is a very old radio technology. But the great thing about this is they own their own spectrum. It's around 1900, 1920. And we have, for the Wirepas MAC transport and routing layer, so the way these devices behave, the radio layer is just, let's say, it's a profile. It's an adaptation. Yeah? The upper layers up to the SDK remain the same. So we can port to this new spectrum, and we have also contributed to develop a standard radio interface technology with the majority of, let's say, what we have learned in terms of coexistence, in terms of usage of spectrum, coming back to the 2000. How do we use the spectrum most efficiently without disturbing others, but creating very high reliability? And we have done this with the success that ETSI published this standard in 2021, I guess, yeah. And it was recognized as a 5G radio interface technology on the same level as mobile 5G radio interface technology back in 2020. So we have now, for this mesh topology, own spectrum that can be used over Europe. That's why you see Wirepas a bit more often now in the smart metering space, because that's the perfect match to have large scale, massive volume networks and have taken the complexity of managing these networks or the need to manage these networks and actively out. Because let's say the design principle is that this, I show you here, yeah, that this meter, is controlling or analyzing its own radio environment when you switch it on, and detects other meters because they are access points and routers in one, and connects to the gateway that brings his data closer to the next wide area network access point, which is a gateway. Yeah. Give you the example, in Oslo, we have 920,000 of those in one network with around 13,000 gateways. Yeah. And the interesting thing is the installers can go there, switch it on, and they scan their environment. They detect their neighbor. That can be a neighbor very close. Then it turns down its output power because of the waste of the spectrum. Or it can be, let's say, depending on the spectrum and the regulation. In the 868, it can be a couple of kilometers. In the 1900, it's exactly the same. So we have outdoor measurements in let's say, rural areas of 2 to 3 kilometers, between 2 meters. But it's exactly the same stack. It's exactly the same solution if you have hundreds of meters in the basement to get out, or if you have a meter which is remote and you need the connection to the next one, which is about a kilometer or two away. And this is the revolutionary thing compared to the existing mesh networks, which I call mesh network generation 1, where you have to create network tables, where it takes very, very long when you, for example, have an outage, that this network comes back. And the cellular solution, which is, let's say, constantly over-promising on low cost and performance when it comes to coverage. Because mobile operators, I fully understand that, they earn 80 euros with me each month on that. With this, how much do they earn? I'm not sure. Yeah. And this can get into a kind of cost trap in a way, or performance gap. And we have merged these two worlds of the, let's say, mesh cost and cellular performance in this standard. And Wirepas, as 5G mesh, as I mentioned below my name, is then the first standard conform implementation of this standard, so that you really can be assured that nothing else can enter this spectrum that is disturbing the quality of the connectivity that you have. So that was a long monologue, but I hope it clarified a bit.
Yeah, it clarified and it opened a number of topics that I would like to dive even deeper with you. So one of those is number of founders listen to my podcast, and I've got often the question, how can they increase the usage and consumer base of their solution? And you just provided one extremely good example. Do what you're best at, exposed easy to use SDK for others, so other developers can build on top of your solution. And this creates that win-win scenario that you are in your excellence zone, and others don't have to reinvent the wheel. They just use your tool, your SDK, whatever. And by that, you get broader adoption. They get better and service. So it is great scenario, and I do recommend that to everyone to follow that path, because building the whole solution is extremely difficult because you've got all of those verticals that you need to cover.
Yeah, if I give you an example from another world, if you are looking into 2.4 gigahertz, for example, and you're planning a massive scale product, yeah, where I have a very good example here, which is here Schaeffler, a very well-known brand. They have created a product where you can monitor machines. Yeah, you screw it in, and they measure the shaking and the temperature and some other parametrics of the machine, and they're replacing the old guy who was running through the shop floor, putting his hand on the machine and saying it needs more lubricants or less lubricants or needs monitoring and so on. So, and this is a very successful product because the connectivity in that is Wirepas. Yeah, so these are also low power routers. In the 2.4 gigahertz band, we have battery operated routers. They last 4 years with one battery and get a lot of information. Today we would say AI of Schaeffler, where they analyze the data and give recommendations what they can do with the machine. The key challenge here is not just to get the data out. The key challenge is you are in a so-called hostile environment. So you are not, as Schaeffler, controlling the shop floor. You don't know how it looks like. So it means also that your installation effort should be minimized. And this is a big challenge if you are designing the application and the connectivity layer. Per network, 5 to 10 devices of those. It's not a problem to go with connectivity solutions coming from the household, like Zigbee or Bluetooth. Yeah, but they have a significant effort to be provisioned, and you have for each solution, for each version and solution, an own way of commissioning and provisioning. You can use public APIs, open source, and so on. But in the end, what you want is, with this and with a smart meter, the second visit on the device kills your business case. Always. The second time you have to go there, you can discuss cents of reduction on the hardware. You can put your procurement guys to the limits for everything. But as soon as the second time someone has to go to the premise, to the hostile in parentheses environment, your case is dead for this place. And this is where massive IoT, and then this cost scales massively up. Yeah, in metering we call this a cleaning rate. And if you look into Oslo, for example, the cleaning rate was very, very low. Yeah, I have to look up the numbers, but it was significantly lower than with any other technology. And this made this case profitable for the utility and therefore profitable for the electricity user, because the grid fees and metering fees are not rising, because in the end it's the consumer who pays. Yeah? And in this case, exactly the same. Customers don't want technicians from a third-party company coming to their place every now and then. Yeah, it has to be installed. Even this one can be installed by the customer himself, and then nobody else should ever touch this device until the end of a defined life cycle.
That's the plug and play experience that the customers are demanding.
I avoid this wording of plug and play. It's really about the service that you bring. Yeah.
Once again, this is the win-win scenario. You reduce your cost because, as you said, if we need to send technician second time to the same location, you're losing money because of the margins. And customer is also not happy about having someone walking around the factory, because that is whole trouble of its own.
And you as a citizen, when a smart meter guy is installing it, you have to be at home. When he comes a second time, you have to reschedule your private stuff. You don't like it. It's exactly the same, let's say, value that you bring here.
Even bigger value, because that doesn't impact my daily routine, especially when that technician won't show up and I need to call once again, because maybe that's just in Poland, but that happens. Let's go to some other topic, which is extremely interesting from my perspective. You engaged with the Energy Web Foundation and connecting devices to blockchain. Let's elaborate a bit on that from the security perspective and autonomous energy transfer, so devices can sell and purchase energy. You briefly talked about it during the EV part, but let's focus on the blockchain and how it can actually provide a tangible value to this solution.
It's a very broad sector. So we always got to see when does blockchain make sense in the term of advantage to all players. Yeah, it's when nobody trusts nobody and there is no central entity that can settle and acts as a trust anchor. Yeah, that's where blockchain in general is a viable solution. Energy Web Foundation was mainly founded to avoid a centralized CO2 certificate market, for example, where you have to register your device, like we see, for example, in Germany with all the solar installations dating back 10 years, 15 years. There's a huge paperwork to make them part of the grid. And then you get your subsidies, but not based on real measured values. You get your subsidies based on some, let's say, calculations, prognostic data, weather data combination. So it's a pure algorithm designing your money flow. It's not the real world. And now you need the real world data because the grid requires that. And on the other hand, we are moving away from subsidies down to markets. And the market for CO2 certificates makes this, let's say, information, how much CO2 your or carbon emissions your photovoltaic, for example, is saving, is giving you a certificate which you can sell then to BMW, Elon Musk, or whoever wants to buy that in order to balance its own carbon footprint. So This has a value. And how do you monetize on that value? Because it's a small ticket transaction. And there is no massive players like in the payment that you have the banking system who's always interested in organizing the payment, and still it's too expensive compared to what the Bitcoin advocates are telling us. Yeah, and it's still not so privacy, let's say, proof. In that case, you can compare your, let's say, smart meter or your meter where you have a kind of blockchain hashing in the source of the data. You have to have it really down in the sensor, down in the radio device. You can guarantee that this is coming from your device, that this data is reflecting a certain time, a certain value, and that it is only subject for one entity. Yeah, you can't copy that, and this is the key for the use of blockchain, so that you have this authenticity of the data bound directly to your asset, and that you can directly trade this with other people who require this. Though there you take a lot of middlemen out, like aggregators and so on, or even the aggregators are buying this. The money flow to your wallet is direct. And this is the big advantage, that you can reflect any constellation of assets in a premise, be it a professional premise or like a solar park or a wind park, or even a private premise like my house, where you can then participate in the market, no matter if you have such a small share or such a big share in the area. And this is where blockchain makes absolute sense. Yeah. And the Energy Web Foundation started with this big vision, but they are very successful in a global CO2 emission certificate market. If you look, they are very much active in Southern America, in Northern America, where huge of these solar power plants and wind farms are currently created. In the European regulation, we are a bit lagging behind, but it's coming.
Legislation is always a bit behind technology, and
Should
you're right. Like it should not be as easy to change as technology is, because that might get us into tons of troubles. So to wrap up, what is your prediction for the smart energy market? Because you mentioned tons of different technologies like mesh networking, dedicated communication standards, blockchain. So what is next? What's your hope and your prediction for the smart energy and the energy market in general?
Let's take it the other way around. I would like to see a society, a democratized society, in which anyone can buy an asset like a heat pump, like a solar, like a EV, and can now I use the plug and play, participate in the revenue streams of the energy market, be it as a consumer buying energy from, but not only buying energy from a monopolist, but buying energy from my neighbor in the 15-minute because the sun is shining, buying energy from the other neighbor because his storage is full and he doesn't need it until tomorrow, or buying the electricity even from a bigger provider, or being a supplier for a certain time, or buying energy when the prices are negative, so that you don't talk about the cost of the energy transition, of the heat pump. Oh God, I have to buy a heat pump. It's so expensive. Look at the pricing. Or I'm obliged to build a solar on my rooftop because the house has a certain specification. From this thinking of I have to yeah, great, I can make money with it. Everything that leads to enabling this is going through decentralized technologies like the DECT NR Plus or the NR Plus meshing topologies, or the blockchain, as you say, or the enablement of decentralized energy management, grid edge management. And this makes the whole system more efficient, less expensive, and especially when you look at geopolitics, less vulnerable. Yeah? And I'm a strong believer that we are getting there in the next 15 to 20 years. It will be a very bumpy road because, as you see with the farmers, as you see in society at the moment, if you create something new, sometimes you have to take something away from someone who's used to having this revenue stream, without having too much effort to put in. Let's say it like this. So we will see these conflicts, but I strongly believe this decentralized nature of the energy grid and the citizen participating in the revenue streams is a key element also to keep democracy alive.
That's a great point and great application of technology to change people's lives and nations even, as you said, because this is basically on the nation level. So what's the best way for people to follow you and to learn from you about the energy market?
So usually Wirepas, or I'm going to a lot of, let's say, events like Enlit Europe, eWorld in Essen. I'm also invited this year to join my colleagues in Distributech in Orlando. So these are the good places to have a discussion with us directly. But you can also always go on our website, click on my contact details, schedule a meeting, and have a discussion on how we can work together, how we can together benefit or work on realizing this vision. And as I said, the first step is a smart meter. It's a bit like this payment terminal in a supermarket. You can't have digital cash services without this terminal in place. And this is the terminal. And then you build the services around this. You can reach us immediately because this is our interest to get this started, to get this really up to speed. And by the way, we see this in India at the moment where we have a huge rollout of 270 million smart meters with exactly this in mind. Yeah? Building an energy system that is really sustainable for the good of the people or for the future, and not just for the, let's say, wallets of some people that own utilities over.
And the beauty of it is that system is self-sustaining. As you said, no one needs to carefully look at it, keep it up to date. It will just propagate and it will self-heal and self-organize.
That's our contribution to it on the connectivity side. Yeah? And then the other players can build on top or below, depending on what their strengths are, be it a chipset provider, be it a meter provider, be it a head-end system provider or utility system integrator. This system you can adapt to any governance objective for the energy system that you like, and you can even change the governance over time, which you can't when you have too much capex invested. And then the capex model must stay for the next 10, 15 years. And then you're stuck in this governance model. And that's our contribution is really this flexibility, the cost down, and the reliability.
Thomas, thank you so much for finding time to meet with me today to share your insights. We covered tons of topics. We could have covered way more. Unfortunately, we need to wrap up for today. Hopefully, we will have a chance to meet once again and to dive a bit deeper into the technology and all the aspects that we covered.
Lukasz, it's been a big pleasure. Thanks a lot.
Thank you for listening. Go to thefingers.com to find more materials about the Internet of Things domain. My name is Łukasz Malinowski, the Internet of Things advisor and trainer.